question is asking us to find the probability of, what is the probability that both equations have imaginary solutions? Okay, so the first thing, so it's two events, right? So we've got this one and another one. And remember when it's and, like you have one event and another one, that means multiplication. So we have to find the probability of imaginary and the probability of imaginary, which means that we're going to be multiplying here. So what is the probability of getting an imaginary equation, imaginary solution the first time? Well, there's 5 to choose from, okay? How many of these equations are imaginary? Well, if you bring this -1 over here, you're going to get x squared equals -1. There's an imaginary one. Here, if you bring this 4 over, that's -4. Take the square root of both sides, you're going to have an imaginary solution. You bring this one over here, you're going to get 25. That's just plus or minus 5. This is real, okay? This one, x squared equals 16. This one's real, okay? This one here, as you can see, you're going to get an imaginary answer as well. And I hope all of you understand this. The idea here is x squared is equal to, I'll just use -9 for the example. That equals x squared is equal to 3i plus or minus. Actually, let me change this to x is equal to plus or minus 3i. So you understand that's what we're talking about when we talk about imaginary. Okay? So there are a total of 3 imaginary solutions. So the probability of for a random choice of getting an imaginary the first time is 3/5. Okay? But now for the second one, we no longer have 5 equations left. We only have 4. And because we've already chosen one of the imaginary ones, we're down to 2/4. Okay? When you multiply those, 3 times 2 is equal to 6, 5 times 4 is equal to 20, and that reduces to 3/10. And that's how we know that the probability of randomly choosing an equation that has an imaginary solution is equal to 3/10.